You can't see it, you can't touch it. But quantum mechanics might be the most accurate and strangest science we've ever known. This is the story of quantum mechanics. Imagine a wall with two slits in it. Behind the wall, there's a screen. Now imagine shining a light at the wall. You'd expect to see two bright lines on the screen, right? That's what common sense tells us. But in the quantum realm, things get truly bizarre. When scientists fired individual particles of light, photons, at the two slits, something unexpected happened. Instead of two lines, they saw an interference pattern on the screen, a pattern of multiple light and dark bands, as if the photons were interfering with themselves, like waves spreading out in a pond. How could this be? How could a single particle go through both slits at the same time to interfere with itself? It seemed impossible. Yet there it was, right before their eyes. But it gets even stranger. When the scientists tried to observe which slit each photon actually went through, the interference pattern vanished. It was as if the act of observation forced the photons to choose a single path, collapsing their wave-like behavior back into particle-like behavior. This is the crux of the double slit experiment. It reveals a fundamental strangeness at the heart of reality, that particles, the building blocks of everything we know, don't always act like particles at all. They can exist in a blurry state of possibility, a wave function encompassing multiple possibilities, until the moment they are observed. The implications of this are staggering. It suggests that reality isn't fixed and determined, but rather fluid and probabilistic. In the macroscopic world, the world we experience every day, things are generally clear-cut. A coin is either heads or tails, a cat is either alive or dead. But in the quantum world, things are not so simple. Instead, we find particles existing in a state called superposition. Imagine that same coin again, but this time imagine it spinning in the air. Until it lands, it's not heads or tails, it's both, simultaneously. That's superposition in a nutshell. Quantum particles like electrons or photons exist in a haze of possibilities, embodying multiple states at the same time. It's not just that we don't know the state of the particle, it's that the particle itself hasn't decided yet. It exists in a limbo of potentiality, a superposition of all possible states. It's only when we make a measurement, when we try to pin down the particle's properties, that this superposition collapses, and the particle chooses a single state. This is where things get really mind-bending. It implies that our act of observation doesn't just reveal reality, it helps to create it. Before we look, the particle exists in a cloud of possibilities, each with its own probability. Our observation forces the particle to choose one of those possibilities, collapsing the wave function and solidifying a single outcome. Superposition challenges our intuitive understanding of how the world works. If you're ready to have your mind truly blown, then buckle up, because we're about to explore one of the most bizarre and fascinating concepts in all of quantum mechanics: entanglement. Imagine two particles born from the same event, linked together in a way that transcends space and time. You send one particle to your friend on the other side of the world, while you keep the other particle here with you. Now, you measure the spin of your particle, let's say it's spinning up. Instantly, as if by magic, you know that your friend's particle must be spinning down, even though they haven't measured it yet. This isn't just a correlation or a coincidence, it's a fundamental connection, an instantaneous linkage that defies our classical understanding of space and time. This is entanglement, a phenomenon so strange that even Einstein famously called it spooky action at a distance. He couldn't accept that two particles could be so intimately connected that measuring one could instantly affect the other, regardless of the distance between them. It's a level of interconnectedness that seems impossible in our everyday world, yet it's a fundamental aspect of the quantum realm. Entanglement is like an invisible thread connecting two particles, no matter how far apart they may be. It's a deeply unsettling concept, challenging our notions of locality, of cause and effect, of the very fabric of space-time itself. To truly grasp the implications of quantum mechanics is to embark on a journey that challenges our deepest intuitions about the nature of reality. It requires a willingness to embrace uncertainty, to accept that the universe is far stranger and more wondrous than we could have ever imagined. It means letting go of the comforting determinism of classical physics, the belief that every effect has a cause, that the future is predetermined. Instead, we enter a world where probability reigns supreme, where particles exist in a haze of possibilities and where the very act of observation shapes the outcome. Trusting quantum mechanics means accepting that the universe isn't a collection of discrete objects, neatly separated in space and time. Instead, it's a tapestry of interconnectedness, where particles are entangled across vast distances, influencing each other instantaneously. It means acknowledging that our everyday experience of reality, while seemingly solid and predictable, is but a thin veneer over a much deeper, far stranger quantum reality. Think about it. If we truly believe quantum mechanics, then we must accept that observation creates reality. The very act of observing, of measuring, influences the outcome of quantum events. It's as if the universe decides what it's going to be only when we look at it. Objects are probabilities. Particles don't exist in definite states until they are observed. Instead, they exist as waves of probability, spread out over a range of possibilities. Nothing is certain until measured. The future, like the present, is a sea of possibilities, constantly in flux. These are not easy concepts to digest. We've journeyed together into the heart of quantum mechanics, exploring mind-boggling concepts like superposition entanglement and the observer effect. But you might be wondering, what does all this have to do with me? What does it mean for our everyday lives? Well, for starters, it means that the universe is far more interesting, far more mysterious than we ever thought. It means that the reality we experience, the solidity of matter, the passage of time, the very laws of physics, might not be as fixed and absolute as we once believed. It means that we are all connected, not just through social networks or the internet, but through the very fabric of space-time itself. Every atom in our bodies was once forged in the heart of a star, and those stars are linked to us through the quantum entanglement that stretches across the cosmos. On a more practical level, quantum mechanics is already shaping our world in profound ways. Quantum technologies are poised to revolutionize computing, medicine, communication, and countless other fields. Quantum computers, still in their early stages, have the potential to solve problems that would take classical computers billions of years, like breaking encryption codes or simulating complex molecules for drug discovery. Quantum sensors are being developed for medical imaging, allowing us to see inside the human body with unprecedented precision. And quantum communication networks promise to enable ultra-secure communication, unhackable by even the most sophisticated eavesdroppers. So yes, when you trust quantum mechanics, something strange happens, not just in the lab but in how you see everything. The world becomes a richer, more mysterious place. The line between science fiction and science fact blurs, and you start to see yourself not as separate from the universe, but as part of its grand quantum design. This is mind and matter. Think deeply, question boldly, stay curious.